Okay, we'll go ahead and get started. Hi, everyone, and welcome to today's presentation. How can data cataloging integrate key viewpoints using knowledge graphs? Let me start by introducing you to today's speakers. We have TopQuadrant's Irene Polikoff and Robert Coyne. Irene is the CEO and co-founder, and Robert is our Chief Marketing Officer and co-founder of TopQuadrant. Before we get started, let's review a few logistical items. Please feel free to ask questions as we go along by using your GoToWebinar controls. To post questions, please look on the right-hand side control panel. You should see a drop-down box for questions. If you click on the box, you should be able to post your question at any time during the presentation. We will address as many of these questions as time allows at the end of the webinar. We will also be recording today's webinar, and we'll send a link to the recorded version as well as to the slides. And we will also be presenting a brief poll today, so thank you in advance for your participation. With that, I will hand it over to Robert to get us started. Robert?
Welcome, everyone. Thanks for joining us, and thanks, Christy. The topic of today's webinar seems to be of keen interest to quite a lot of people. A little background on TopQuadrant first. We were founded in 2001. That's the same year that the vision of the semantic web was born. And since then, we've been engaged in applying this technology to create enterprise applications and to make enterprise information meaningful. As many of you may know, that technology has been known by many names, such as semantic technology, semantic web, linked data, but more recently, it's become more widely known as knowledge graph technology. And since 2015, the focus of our company has been to provide comprehensive data governance solutions based on and using knowledge graphs. Today's presenter is Irene Polikoff. She's the CEO of TopQuadrant. And Irene has a long career in information management and pretty deep expertise in applying knowledge graphs to enterprise data governance challenges. In fact, she and other TopQuadrant personnel have been instrumental in helping to create and shape the standards for knowledge graphs through the W3C. What she's going to cover today is informed by working with many industry customers over the last 20 years and more. So first, she'll do a concise overview of several of the different kinds of artifacts that have been in use for data management and governance, including physical and logical models, data dictionaries, business glossaries, data catalogs, etc. And she'll then highlight one of the most critical common challenges faced by data governance practitioners, that is connecting the many different perspectives and aspects of data. She has a lot of insights and practical guidance to share on the best practices and value of using knowledge graphs to support data governance. So with that, she'll conclude with a real-life customer story based on our experience working with a large financial services organization, and a brief demo illustrating how knowledge graphs enable connecting key metadata and the many data governance perspectives that are needed for its practical implementation. And with that, I'll turn it over to Irene.
Thanks, Robert. Thank you. Next time, I'm gonna have to insist that you put your picture here because my picture here looks kind of lonely on the agenda. But yes, as Robert was saying, we're gonna talk about data cataloging and different perspectives that different stakeholders have on data and the needs they have from data cataloging. So with that, I'm going to start by describing a few common artifacts that is produced to serve the needs of those stakeholders, because they are different stakeholders and they do have different needs. As I talk about each of those artifacts, you'll see information on the slide, and it describes this artifact from a number of perspectives. It's like, who creates it, who is it created for, when in the life cycle of managing data this artifact is created, what is the purpose, what format it's delivered in, what it contains, and so on. And we will also talk about, how quote unquote hot a particular artifact is today, because the journey towards documenting data landscapes, of course, are not new. I mean, data cataloging is somewhat of a new term, maybe. I mean, it's very popular today, but the attempts to document data and manage data and deliver that documentation to various stakeholders is definitely, decades old. And some of those artifacts are better known and more in use today. Some of them were mainly in use in the past and maybe not as popular today. So we're going to describe each of them from these different perspectives. So logical data models, probably many of you are familiar with logical data models. They get created early in the life cycle of a system as a way to provide requirements. They focused on a single system, and they created by business analysts, etc. They describe primary entities, their relationships and attributes, and get often delivered in some kind of a paper form, or if there is a tool, maybe some kind of a Visio diagram, UML tool, etc. Some organizations always start their data development, data design with logical data models, and then they create physical from them. These tend to be large organizations with a lot of established methodologies in place. Other organizations not necessarily go through that discipline. So it's, not necessarily a very hot thing, but a very well-known part of the data design, especially when dealing with relational databases. Then there are physical data models. And unlike some other things we're going to talk about today, they're always there, so you can't really say whether they're hot or not. You have a data source, you're going to have, typically it's going to have some kind of a physical data model. So it's always there, and you have technical stakeholders busy with this, data administrators, software developers, etc. The information is embedded in the data source itself, and it's a next iteration up from the logical, data model in terms of having more details, specific data formats, and extending and enhancing what got started perhaps with a logical data model. Again, focused on specific database, single data source, and so on. And from a format perspective, it may be DDL commands if it is a relational database. Otherwise, maybe it's a JSON schema or XML schema or some other way to describe a physical data model. So if you have a database, many data stakeholders, of course, interested in its design and its structure and what it contains. And pretty much any database you have today, definitely with relational databases, will output some kind of a data dictionary. Again, it will be a document, maybe a spreadsheet, maybe Word, etc., that will let interested parties take a look at it and look up the design without actually having administrative access to a database and without having to query system tables, etc. So many different roles may be interested in it. Now, the data dictionary as a concept is started as an idea of documenting a single source. But of course, what we are most interested in is a broader picture. I mean, single source is important, but when you're dealing with enterprise data, you want to have a broader picture, and you want to understand data dictionaries across different data sources. And that kind of idea gave birth to a term, metadata registry. I have not heard that term this much in recent time, but let's say 20 or 25 years ago, it was very popular, especially with government organizations. And essentially, that's a combined data dictionary. That's a data dictionary that spans multiple data sources, and it gives you information about what's contained in a database and in multiple databases. And the goal is to serve as a single system, one-stop shop where you could go, different stakeholders could go and find out information about data. When this first concept started to get adopted in organizations, metadata registries were typically fairly geeky and fairly technical, but they contained a lot of useful information and started going more towards direction of also presenting a business view of the data and not just technical details. Another kind of a similar counterpart to, as we say, like data dictionary and metadata registry is kind of counterpart to the physical data models, presenting multiple physical data models in accessible way in one place. Enterprise logical data model is another type of an artifact that, again, was very popular in the past and not so popular now. And the reason we talk about it, because all those kind of old and more mature concepts, they actually give birth to new concepts that we could see how they have been reimagined and rethought today, and see it more of a perspective of a journey. So the enterprise logical data model is essentially a logical data model on steroids, focusing not on a single system, but focusing on the multiple systems within the enterprise. It's much harder to produce because now you don't have a context of a single system. You now have to think about much broader context. And anytime you have broader context and different viewpoints, you have to manage agreements between different stakeholders. Also, the whole modeling exercise is fairly challenging. And the reason this type of thing went out of fashion is because it was difficult. It was labor consuming, required certain skills, required a lot of work, and benefits and results of that work were not necessarily immediately clear to the enterprise. Quite often, these enterprise logical data models were again delivered in a paper form, and organizations would spend months and years trying to paste and put together something like this. I remember visiting one government agency about 15 years ago or so. They had a war room that was a huge, huge conference room, and it was pasted ceiling to floor with pages and pages of their enterprise logical data model. And if you wanted to interact with it, you wanted to understand it, well, you had to go to that room. So not only that process was very labor consuming of putting it together, but the process of delivering it to anyone interested was really not that practical. So from all those early developments, I think an industry learned a number of things, and those number of lessons learned, they gave birth to what is actually being actively practiced today, and what is being what is practical and popular in the industry today. And that is the fact that you need, if you produce those artifacts, you need to produce them in a way that it's easy for the stakeholder to access. You also need to produce it in a way that addresses the different viewpoints and the different needs that they have. it needs to be easily evaluable, because if you are trying to create this whole body of information in one swoop, that's going to take you a very long time. So the practical approach is to start small, deliver some value, and then evolve from there. So tangible value early, results for business, etc. And that moves us to some of the newer artifacts, and that the things that, as I said, that are being practiced today, and that's considered to be state of the art and state of the practice. One of them is a business glossary. You probably heard quite a bit of it. And the difference between a business glossary and, let's say, a logical data model, for example, is that it's more business oriented. Because it's hard to design those logical models, we, as an industry, I think everyone agreed, let's do something simple. We still need to give business context to our data elements, but instead of trying to model that in detail, let's just have glossaries of terms with some clear definition, so they could be used to establish shared understanding across multiple stakeholders, and they could be also used to ground or connect data elements and physical data models to those shared glossary terms. In terms of a format, well, I mean, a simple way, again, that could be a spreadsheet, that could be a document, but increasingly people are using some kind of a tool because it allows more richness, it allows more flexibility, and it allows connecting business terms to other aspects of the data landscape. Focus here is very much on the business, and therefore business is invited to participate in crafting such glossaries. But even if you look at it simply from the perspective of let's define some terms and create some definitions for them, as you move forward, you will very quickly start to realize that actually to have a useful business glossaries, you still need to describe those terms in more details than just little snippets of text definition. So for example, here we're looking at a term purchase order, and then another term blanket purchase order, and then purchase order payment terms. All of those can be thought of as business terms, and we could define them succinctly and have definition that we as people could read and understand. But as we try to describe them more, different other aspects come into the picture. For example, how do those terms, how do they relate to each other? And we could see that there is actually a number of relationships between them. A blanket purchase order, for example, is a type of a purchase order. So it's kind of a narrow concept than a purchase order generally. But the payment terms is something that you will have within the purchase order, just like you would have a purchase order number, a purchase order delivery terms, etc. So the relationship is different. It's a containing relationship. So now you are starting to move into something that's starting to resemble more a logical model with an entity such as a purchase order, and then some attributes and relationships, such as payment terms, etc. That's a part of it. So as we progress, business glossaries become richer and richer, and can, to some extent, start to resemble logical data models. But here we have a flexibility to do something that is simple and then evolve it into something more sophisticated if we decide to, and when we decide to, and maybe not uniformly, but only for the most important entities in the enterprise. And then the kind of a title of our talk, and probably the hottest term or concept of them all today is a data catalog. So what is a data catalog? When you look at it in a little bit more detail, essentially it's very similar to the metadata registry. So it's maybe one of those rows by any name is still a rose, but it's definitely, I think, changing a name signifies somewhat of a different change in focus. It's easier to understand. If you ask your typical business user, do you think we need a metadata registry? You'd probably have to spend some time explaining what it is. If you use the term data catalog, it's more readily understandable, and most people will agree that, yeah, that would be great to have a data catalog. So that focus on stronger connection and stronger serving the need of business users, especially in today, since data is becoming more and more accessible, more and more people are working with data, and more people are data stakeholders, with self-service and so on. So that movement towards having something more readily understandable, more usable, etc., is user-friendly is very strong. But the type of information that you capture is a similar type of information. You bring in all the technical details of your data sources, and then you try to connect them to enrich and connect them with additional information. And that could include samples, that could include your data samples, that could include connections to glossary terms and so on. So everything that you would normally previously see in data dictionary and metadata registry. So the common theme that we see here is a move to beyond one system to this one-stop shop, single view across different artifacts, and more of a holistic approach to data cataloging, where separation between those artifacts truly starts to blur. But still, each artifact offers a slightly different take, or slightly different approach towards that same objective. However, wait, there's actually much more to the picture than what we just described. When you start talking about data, other things and artifacts that come into play are, of course, requirements, because it all starts with requirements. And requirements often encompass regulations as well, regulatory requirements. There's reference data. The moment you start talking about your business terms or your logical entities, your physical entities, you also start to talk about and manage some control sets of values that those entities and data elements can take. If it's a country, it's a list of countries. If it's statuses, it's a list of status codes. So that's also part of the description of the data. And when you start to describe this broader landscape, it immediately becomes about complex information flows, ETL processes, which in turn can be captured at the different levels, at the logical level as well as the physical level. And since we are talking about data governance, we also have to talk about the policies and processes around managing data. That's also part of the picture. So many different viewpoints, many different artifacts to bring together. And that is often a challenge that has been a challenge in the past, and that continues to be a challenge today with more modern efforts around data cataloging. So we'll see all those different artifacts, and really to provide a connected view over all this information and deliver it to different stakeholders, they need to be connected. And quite often today they are living in silos, and organizations are struggling to deal with it. One way of dealing with it may be to introduce new roles, hoping that you throw new types of roles and new types of people into the problems, and that's gonna solve the problem. But what we see as key to solving the problem is really establishing this end-to-end connectivity of this information and creating an environment where those different artifacts and different viewpoints can come together. And this is why we see that a solution to this type of a challenge in knowledge graphs. Because when you look at any object in this data landscape, you see different aspects of it. So this viewpoints that I mentioned, like if you're looking at the database table, for example, you may describe it from the aspect of what regulations it must comply with. Some of the stakeholders will be interested in that. You can describe it from the perspective of how it's being processed, what applications touch it, what applications use it as an input and output. You could describe it from the perspective of what's its structure, what columns it has. Is this column numeric? Is it a string, and so on. All those are valid viewpoints, and you need to be able to manage and capture all of them in a connected way. And we believe that knowledge graphs give you that ability, that and more, which kind of brings me to the topic of the knowledge graphs in general. And I'm going to give you a short introduction to the knowledge graphs. But before we do that, and help me to gauge my presentation, maybe we could ask you to let us know how well are you familiar with knowledge graphs. Christy, can you start a poll?
I just launched the poll. Everyone should see that on their screen. If you'll just take a few seconds to select all the answers that apply to you, which best describes your understanding and or use of knowledge graphs. Oh, actually select one. I'm sorry, I select all. Select one that applies to you. We'll give a couple more seconds. It looks like almost everyone has voted, and I will share the results. Okay. Okay, I am going to close out the poll and share. Here we go.
Okay, thank you. And we have a pretty diverse, actually, group across all the categories. Okay, that was useful to know. Is my screen visible again, Christy?
Yes, sorry, yes, I was on mute, yes.
Okay, all right, so let me talk a little bit about knowledge graphs and what we mean by knowledge graphs and where they come from. So essentially, knowledge graphs can represent any information in the domain that you are interested in. And it represents it in the form of a graph. In other words, a network of connected nodes and links, as opposed to, let's say, in the relational databases, you have tables and rows. So it's very good for connecting information together in a flexible way. It's also capable of capturing the underlying facts, data, as well as models or metadata that this data is based on. And it captures them essentially in the same way as part of the knowledge graph itself. And as a result of it, it also supports ability to define rich rules. So even richer than just metadata, but specific rules about data that lets us check its conformance to those rules, and also lets us infer additional facts to so-called inferencing. And another important fact about knowledge graphs that they're actually based on open standards, top to bottom, and that's important in data governance because you want to be you want to connect and break silos as opposed to having different silos like silos of data and now silos of metadata with all those disconnected artifacts. So using standards are important to connectivity. And also today there are increasing number of public knowledge graphs that people could actually take advantage to and connect to because they are based on the same standards. So we have a very small example to the right. It's not really in data cataloging kind of example. As I said, knowledge graph could represent any domain of knowledge. So in this particular example, we're just talking about a person called James, and we have some information about James. He has a father. We know who the father is. He has blue eyes. So that's kind of leaves at the level of data or facts. In case of data cataloging, those facts could be, we have a table, and that table belongs to some database, and it has 5 columns and so on. And then at the next level, still in the knowledge graph, so it's still connected and accessible together in the same way, is a model where it says about, well, what does it mean to be a person? What kind of properties, attributes can a person have? Well, a person could have eye color, and those may be some selection of colors that are possible. A person could have parents, and actually they could have only 2 parents, and so on. And even richer than that, extending this type of a data structure type of models with additional semantics, you could also have pretty sophisticated rules. For example, if both of person's parents have blue eyes, then this person will also have blue eyes, and that could help us to infer additional knowledge. So if we know that James's father and mother have blue eyes, then we could infer that James has blue eyes. And when you can connect it to our data cataloging kind of interest at the model level, here we would have descriptions of what it means to be a database table, what kind of properties and attributes you may have, a number of records, connection to a database, maybe type of data, operational versus reference, columns, maybe connections to logical entities, people responsible for curating and stewarding this data, applications that are using it, and on and on. That would all be in a model type of a space. And various rules, they may have to do with how you can enable connections, automatic inference of connecting the data elements to, let's say, business terms. So that would be an example of the rules that you could have in place. So this shows us that there can be different types and different instances of knowledge graphs, dealing with different type of data, and also different levels of abstraction from the underlying facts to models and rules. So where did this concept of knowledge graphs came from? It's about 20 somewhat years old, and was first introduced by Tim Berners-Lee, inventor of the internet. And as part of creating of the internet, Tim's vision from the beginning was much broader than just connecting documents over the web. He also wanted to connect data over the web, and that meant managing metadata for the data. So back in 2001, W3C, which is World Wide Web Consortium that Tim is the director of, started working on a set of standards for expressing that. And that work has progressed, and as Robert has mentioned, I actually participated in the last few years in the development of some standards as well that have to do with next generation of expressivity on the web, a standard called Charcoal Shapes and Constrained Language for the knowledge graph. So as standards have progressed and matured, and around 2012, we started to see a very strong movement in the industry around those concepts. And that was pioneered by Google, and very quickly all other major search companies picked it up. Their interest was to manage structured data in addition to managing documents. When you do Google search, you see a lot of structured information, and the information you'll see about a person will be different from the type of information you'll see about the city, let's say, a location, because there are different entities. So all of that is described in this large knowledge graphs that are managed by Google, Bing, and other key search engine vendors. And then, so that was kind of first broad use and popularization of those concepts that have been in development. And then the field essentially exploded in last year and this year, where knowledge graphs are very heavily in the news. There are conferences around knowledge graphs, and it's probably the most popular type of a data, the most popular of the new NoSQL type of data representation today, and it's being used in a number of places and a number of kind of applications. Very important and useful for flexible traversal of data in terms of connecting different graphs, as shown in this example. For various graph analytics that has to do with shortest path, centrality, different other statistics. Ability to integrate data. So since graphs are about connecting, then the whole idea of connecting different data sources around the canonical data model and mapping to that main data model and enabling data integration and data aggregation as a specific subset of data integration. And of course, information insight. So when you bring all of this together and you have this flexible, connected representation, you start to look at it from the perspective of finding new relationships and finding new insights. And this is where the inferencing and reasoning plays a role. A specific example specific to data governance that kind of brings all of these aspects together is data lineage. So when you think about the data lineage problem, it has both traversal of connected graph. If you think about all those different data sources and data elements essentially linked together in the process of data processing. You have to be able to find those connections. You have to be able to abstract or roll them up at the highest level, because otherwise it's just going to be too detailed and you will not see forest behind the trees. And of course, it's useful in data integration and data aggregation, and that's why we look at the lineage as well as various compliance use cases. So all those typical use cases for knowledge graphs, when you look at them, I think importance of those use cases and capabilities for data governance becomes apparent. And I previously already tried to give an example using the data cataloging kind of an example, and I have some screenshots that go in that direction and will help there. So this is a set of columns in a table, the employees table in the infamous Northwind database. And they're shown here as nodes in the graphs. In a graph, connected it to a table using column of relationships. And we see that this table is then connected to a database, and we see that the type of this node is a database and database table. So all of those are the kind of facts that will form a data catalog. And those facts, they are expressed in the knowledge graphs in the smallest canonical form as simple triple statements. So of subject, predicate, and object. So something like employees is a table. Actually, this is a column, but it's a type column, and it's a column of a table. So those are the underlying kind of little statements that connect together to create this broader graph. And from the perspective of the model, we could zoom into the database and see a richer model behind it. It's a class and has some parent classes that describe it from different perspectives. And when we look at it from a perspective of being traceable, so a class of all the traceable entities, what does it mean to be traceable? Well, it means that you may have a connection to a data requirement. That's a type of traceability. You may have some kind of a connection derived from, so what this table was derived from. You may have a mapping to, let's say, a glossary term. That's another aspect of traceability. So this gives us a model for describing different properties, attributes and the relationships of a database table. This type of a rich representation is very important for data governance, because in data governance is essentially a connectivity problem. So it requires connecting a lot of different information together in an open, contextual, and extensible way. And that's what knowledge graphs provide. So we could describe a data element such as customer name column from many different perspectives. Who is responsible for it? How critical is the data in it? So those are more of a business and management kind of terms. What table it's part of, what method it may be obfuscated by. Those are more of a technical terms, so different stakeholders, different perspectives, but possible to capture all of them, and possible to define by creating this knowledge graph model what exactly you want to capture. With that, let me quickly switch to a real life example of a customer using a knowledge graph for representing their broader end-to-end data catalog. So first, a little bit about this situation that they started with. So this customer is a very large financial institution, and they already had a mature data governance program in place. And many of the artifacts that I was describing earlier, they've already had in place. They obviously had logical and physical models, and that particular organization has a strong methodology in place where everything starts with a logical model. So they had all of those in place separately, sitting in those tools. They, of course, have a lot of data sources from databases to data sets. And as most organizations have, they have requirements in various documents and formats. They had variety of ETL scripts. They even put together a business glossary, and that was sitting in yet another tool. So that was their starting point. There are lots of different artifacts, all actually disconnected. And their goal was to take all this available information and put it together in a knowledge graph in TopQuadrant Edge in connected way. And the reason they were doing it is because they wanted to fundamentally transform how they were managing information and get a number of benefits from it. Operational efficiencies, better compliance, and better analytical insight as a result of bringing all of this together. So let's talk a little bit about the results. The last we know about, which was probably a year or so ago, they've managed to bring together about 500 logical models with more than 50,000 of entities. Since this is an organization where they're doing logical modeling and they're doing physical modeling, so there's a similar number of tables, and now all of them are connected in the knowledge graph. Altogether, more than 1 million of data elements. They also brought in information about, I think over 1,000 applications, and they brought together many different ETL processes connecting that information. So cataloging all of this, they also established ongoing ingest, so that gets updated on a regular basis as the underlying data sources get updated, and use this body of information for various reporting and metrics for stakeholders that have different roles and different perspectives. So they establish both dynamic access to this information because it's easy to browse and explore this information, as well as establish some commonly useful views for different roles and different stakeholders already pre-canned over this data. So what they have discovered was somewhat surprising for them. Now, this is the sheer number of different entities and data elements was actually surprising to them, because in reality, no enterprise has over 1 million of data elements. So there was a lot of repetition and a need to connect them better to some common data elements. So they didn't even know before this how many entities they had. This is an organization that had an organizational mandate, a long-standing policy that all data entities must be defined. And you're supposed to put them in a glossary before you start using them in actual databases. So that was a policy. However, when they brought the data sources together with their glossary and put it all in one place where they could share and navigate, they discovered that actually only 8% of their data elements are defined, and it was a smaller percent of their entities or tables are defined. So that was very surprising, and it caused quite a bit of a even political kind of upheaval, because they did not expect that to be the case. In some areas and systems, the coverage was much better than in others. So overall it ranged between 0 and 70%. They were also surprised that actually the entities were less defined than elements. There is a smaller number of entities, so you would logically think it would be the other way around, but for some reason they had much lesser definition of their actual entities than they had of data elements. So a lot of interesting input, and one of the lessons learned is that, again, if you have all those disconnected systems and you just put policies in place and you rely on policies to enforce certain things. Because the artifacts are disconnected, the enforcement tends to be weak, and you don't even know what you're enforcing or what you're not enforcing unless you bring this information together. We like to talk about something we call data governance triangle, because it kind of describes different aspects that that one needs to be concerned with when you're doing information management. So there is an executive aspect that has to do with policies and framework and roles and methodology. There is a representative aspect that has to do with just capturing all that there is to capture, all those terms, data elements, catalogs of applications, etc. And then there's applied governance that brings these two perspectives together and connect them towards delivering some kind of a goal, be it better understanding of a lineage, be it better understanding of data quality, or better understanding of data compliance. So all of these aspects we believe need to be addressed in the overall data cataloging and data governance effort. And as Robert said earlier, I'm gonna give you a very quick short demo. We are running towards the end of the webinar, and in this demo example, I'm using an example of some medical enterprise, and you see different aspects of this information that I just described as they captured in the knowledge graph. So from the governance that describes roles, metrics, different governance areas over this data landscape, users, and so on. The models that actually describe the information that's being managed. And then the actual information, ranging from reference data sets, glossaries, maybe forms, reports, documents of this kind, catalogs of data sources. So this is something that's part of the graph that we're calling data asset collection. Information about applications, that's what we're calling technical asset collection, all the way up to describing business type of roles that interact with data, and towards data lineage, and so on. So let me show you an example of how something like this would look in Edge to make it a bit more concrete. So here you see TopQuadrant Edge, and the different type of graphs, we're calling them asset collections, that these are just the categories that get managed. And you see how many of them are actually populated. So in this environment, I have 3 reference data sets. I have 5 type of data sources that were cataloged. I have 2 catalogs of different applications. I have some lineage connecting them. And we could take a look, and you could see that I also have some governance information, such as roles and stakeholders, etc. And we could look at the actual lineage model describing connectivity between connectivity of information that produces some of the artifacts by clicking here, but I have it already open in the tab here. So that particular I'm zooming in here on the patient discharge form, and they could see how it's being produced. So there are different software systems and software modules that take data all the way from the data entry point. Like patients interact with patient administration system. Nurses may interact with medical admission module, and the data flows all the way through those systems in the course of treating of a patient. And in the end, all of this data gets processed to produce this patient discharge form. So this is a high-level abstraction in terms of connections. I could drill into any of this to see more details. So this is kind of a logical lineage view. If I wanted to see more detail, I could click and see details of the data flows, for example, to see how information goes from the patient data management system, and see that it gets transferred to this form, a table or a view called patient procedures. And if I wanted to see more about it, I could click on it and see that indeed it's a database view. So since it's part of the catalog, I see that it has operational data. It's a view of a database. It has some input columns. It has some output columns. So this is the actual view, and it combines some input columns to create it. And we could even see a data sample, and there's lots of other possible fields that are not necessarily populated here. And if we want to explore this information more, we could go and look at the input columns and see where they come from, what's their physical type is, etc. So that's part of the data catalog that deals with the data source itself. We could also get more information about, let's say, an application that is used to process some of this data. Again, it's all connected, it's all available here, and you see the application here is a patient discharge module. You see it's producing a discharge form. It uses these various reports in production of this discharge form. It has dependencies on the software, and some other software has, a dependency for it. We could go to a form and see more information about the form, all the way to specific form items, and how they may be connected to a glossary terms, for example. So all of this linkage and connectivity is in place, and I'm gonna finish by just showing a diagram that of this that looks more like a graph diagram. So you see that how this module uses some other modules, how it produces information assets, and you could continue to explore and that graph to see more information. So in conclusion, the key takeaway points that I want to focus on is that the goal of data governance is to make it possible to answer various different important questions for a pretty broad range of stakeholders. And that requires different viewpoints, that requires different artifacts. And all of these artifacts get produced as in a course of managing data. In order to answer those important questions, we need to bring this information together. And the knowledge graph offers a powerful way of doing this, powerful, flexible, and adaptive way of doing it. And TopQuadrant is a platform, of course, for data governance that is based on open standards. And it's one of its powerful capabilities is ability to not only capture this data, but also enrich the knowledge graph that gets captured through additional reasoning, using rules, using machine learning, and make this information available to both people and APIs. And I think I've taken most of the hour. I don't know, Christy, do we have time to take a couple of questions maybe?
Yep, I think so. The people that want to hang on, we'll go ahead and take a couple of questions. Let me go ahead and see what we have here. Let's start with this one. Why are knowledge graphs a better technology for data governance?
Okay. Well, I was hoping that at least partially the answer to this question will come from my presentation, but to make it a bit more succinct than what I just described is, well, they are very expressive. So you could express all sorts of information from the technical structure to business concepts and business requirements. So expressivity, ability, they're very flexible. So you could, and that kind of goes together with expressivity. You could put any kind of information you need there. Connectivity, you'll be able to connect those artifacts. And then evaluability, so you don't necessarily need to put everything or capture everything from the beginning. You could evolve and expand it, not only from the perspective of bringing in more information, like capturing additional data sources, capturing more details on the lineage, let's say, bringing in information about regulation and regulatory compliance. So you could do that, but you could also evolve and expand it in terms of describing the kind of information that you want to capture. Let's say you need additional attributes or additional characteristics, or even a whole new type of entities. You could just easily add it to your knowledge graph model. You don't have to restructure data. You don't have to reorganize the data. It's a living piece of information that just gets extended over time in a very flexible and powerful way.
Okay. Thank you, Irene. Let's take another question. I see some folks are hanging on. How about, are knowledge graphs different than property graphs?
Okay, that's a good question. I think it must come from someone that already has some experience with graphs. And in fact, I think we are planning a webinar on that topic, and we have a white paper out on that topic. So maybe if we provide responses to questions, we could also provide a link to a white paper, and it could be found on our website. So in short, there are different graph data models are possible. And there are two most popular ones today are property graphs, a la Neo4j, if you're familiar with that. And then the knowledge graphs, or RDF graphs. So it's a different data model, and also nodes and links, but there are some, there's a number of differences in the data model. One important part with RDF graphs and knowledge graphs, as I described, that you could capture in a graph not just the underlying facts, but you could actually capture the model, and you could evolve it incrementally. While with property graphs, although modeling is important, it's basically done on a piece of paper, and then data gets loaded in the graph, and the model is not part of the graph, so you cannot create it, you cannot take advantage of it from the perspective of reasoning, etc. So knowledge graphs are more expressive. Knowledge graphs are based on standards. There is no common standard for the property graphs. It's more kind of an industry term, and every vendor implements it in a different way. And there is a number of other differences, but I think it's a pretty rich topic, and it's we invite you to a webinar that will be focused on that.
Right.
And take a look at the white paper. Yeah.
Yeah, we'll be promoting that webinar shortly, so be on the lookout for that. Let's take one more question. We still have several folks online. This one, here we go. Are definitions in business glossaries considered to be normative versus informative, What is the governance model?
That's an interesting question. So in my experience, and I've tried to touch on it when I talked about business glossaries and talked about that there's really more to it than just definitions. There's also relationships, etc. And I haven't talked about it, but another important part of it is that in reality, business terms exist in context that can be both local and global. So if you take a term, let's say, such as customer, it could mean different things for a customer support group versus marketing group. And one important benefit of knowledge graphs is that you could capture both those local kind of glossaries as well as more global shared glossaries, and you could connect them in a flexible way. So you could say, this is the terms as being used by my customer support department, and this is the terms that we all share in the enterprise, and these are the connections to them. This is how they map. This is where they're the same, or this is where they're different. You could establish all of this. In terms of normative versus informative, I think there's different degrees of them. So, and if that kind of aspect is interesting, you could actually capture it as an attribute, and you say, well, this is a normative term, and this is an informative term. You could essentially capture anything that's important for you, and organize it in a way you want to. I also briefly touched on the governance model itself, saying that it is part of the graph. And because graphs are so flexible and able to capture different types of information, in Edge, we have a graph that is called governance model. And that contains governance policies, governance processes, different roles, metrics, etc. So part of the establishing governance would be populating that governance model, workflows. So populating it with the way you actually want to operate. So that all those aspects, like what the model for the policy, the model for the processes, the model for the workflow is in place. But what you need to do as an enterprise is organize it and populate it in the way you want to operate. For example, Edge ships with a number of pre-built governance roles, like data steward, business steward, etc. But this is all configurable and flexible. You could add your own roles. You could deactivate the roles shipped with Edge to align with the roles and processes you'd have in your organization.
Okay, thank you, Irene. I think we're about 10 minutes over, so we should probably go ahead and close out today's webinar. Thank you, everyone, for attending. Thank you, Irene and Robert. There were some questions that we were not able to get to today, and we will be providing answers to those questions in the form of an email response to all attendees, as well as a link to the recorded presentation and the slides. Thank you, everyone, for your participation, and have a wonderful day. Thank you.